The second part of this session is solving exponential equation. We will look at one particular type in this section because we don't have enough property to talk about all the cases. So the property that we're going to use in this section solving exponential equation is this. If you have one exponential expression on the left hand side equal to one exponential expression on the right hand side with the same base, okay, with the same base, then in order to be equal, we can say that their exponent must be equal to each other. So we can drop the base and then just say that logically those exponents must be equal to each other. So the key thing, once again, you have to check, can the exponential expression can be written as one exponential on the left hand side, one exponential on the right hand side with the same base or not. If we can rewrite that, this kind of exponential equations can be considered as elementary type, which is not difficult to work on it. Okay, so let's take a look at on example 1. So on the left hand side, I have 3 to the 3x minus 2 power. On the right hand side, I have 81. Clearly, 81 can be rewritten as 3 with the base 3 in terms of exponential. So now I can rewrite it as 3 to the 3x minus 2 power is equal to 81 is basically 3 to the 4th power. So now this is exactly in the property format, right? On the left hand side, one exponential expression. On the right hand side, one exponential expression with the same base. So therefore, according to the property, I can simply say that their exponent must be equal to each other, otherwise their value will not be equal. Now that helps us to easily solve this variable x. So which is add 2 to both sides and divide by 3. So therefore, my answer will be 2. So this is the final answer. Moving on to the next example. So in this example, we need to do the manipulations. And notice that on the left-hand side, I have 7 to the x power divided by 7 to the 3rd power is equal to 49. And clearly 49 is 7 to the 2nd power. So on the right-hand side, I can clearly see that y to the 2nd power. Now, you have to remember the properties of exponent in order to rewrite the left-hand side into one exponential expression. Remember this, recall. We need this property for this problem. X to the n power over x to the m power, that is equal to x to the numerator exponent minus denominator exponent. So the left-hand side, I can rewrite it as 7 to the numerator exponent minus denominator exponent by using the properties of exponent that we learned before. Now this looks like exactly into the property format that we have. One exponential on the left hand side, one exponential on the right hand side with the same base. So therefore, in order to be equal, their exponent must be also equal. With this logical statement, I can easily solve the equation, and then therefore my x must be 5. Moving on to the next example. E to the x to the 2nd power times with e to the negative x power equal to e to the 6th power. We already have all of them in the same base, but now the problem is on the left hand side, I need to make sure it is one exponential term. So we need the help of the properties of exponent. So recall, in this case, we know that x to the n power times x to the m power, that is equal to x to the n plus m power. So the left hand side, I can rewrite it as e to the x to the 2nd power plus negative x. which basically means e to the x to the second power minus x is equal to e to the sixth power. Now we have one exponential expression on the left-hand side and one exponential expression on the right-hand side with the same base. So therefore, according to the property, it is logically to say that in order to be equal, my exponent must be also equal to each other on both sides. And that helps us to get a quadratic equation to solve. How do we solve quadratic equation? First, move everything to one side. Try to factor. If it is not factorable, we use quadratic formula. So it will be x squared minus x minus 6 equal to 0. When I factor it out, that is factorable, so it will be x minus 3 and then x plus 2 equal to 0. Using zero factor property, it will be x minus 3 is equal to 0 and x plus 2 is equal to 0. So therefore, x is equal to negative 2 and x is equal to 3. So this one, we have two solutions, negative 2 and 3. And this concludes this section.